Good morning and welcome to the 2019 Public Sector Summit. Just a few housekeeping things before we begin. Emergency exits are in the front and back of the room should we need them. Bathrooms are out the back and around the corner to the left. Please silence your devices and please provide feedback for this session in the event app. All sessions are recorded and will be available a couple of weeks after this event, so you can download and view. And today, our session right now is bringing a data platform back to life through AWS and Tableau with the Iowa Department of Health. So let's welcome our speakers, Rob Walker from the Iowa Department of Health and Ryan Malecki with AWS.
Good morning, everybody. My name is Rob Walker, and I'm an epidemiologist and a data scientist with the Iowa Department of Public Health. I'm part of the Environmental Services Bureau, where I manage the Environmental Public Health Tracking Grant. Essentially, we have a data portal that brings both environmental data and health data together into a single place for public consumption. To start off, I was asked to say a few things about myself and my personal things. My first job in public health was actually as a disease investigator. Basically, I went around tracking people down who had an STD, convinced them to give me all of their partners, and then went and got them all tested and treated. So talking to a group like this is quite a bit easier than that. And so Iowa is one of 25 grantees from the CDC for the tracking grant. Many of those states have a siloed system. Well, Iowa took it one step farther, and we made this a department-wide project. As required by the CDC for any publication, I created this presentation as part of the IPHT grant funding. However, I do not represent the official position of the Center for Disease Control and Prevention. Today, we'll explore the background of the tracking grant, what the infrastructure was that we first built it on. Then we'll look into the process of upgrading the portal and the journey this transformation took. Along the way, we migrated Tableau and all of our data to AWS. I'll reveal what our future plans are with Tableau and AWS and cloud computing. Finally, I'll present some examples of what we've done in Tableau and AWS, and we'll dive into some of the risks, the challenges, and the benefits that came out of this journey. So first of all, what is environmental public health tracking? Tracking is an ongoing collection, integration, analysis, interpretation, and dissemination of data on environmental hazards, exposures of those hazards, and the health effects that may be related to those exposures. The goal of tracking is to provide information through a public web portal that can be used to plan, apply, and evaluate actions to prevent and control environmentally related diseases. This was the atmosphere during our first grant meeting. How do we manage and display all of this big data at Iowa Department of Public Health? To have a better understanding of the path we chose, here are some of the grant requirements from the CDC. We were required to have data presentation and maps, graphs, charts, and tables that can be downloaded. Not only were certain data mandatory, but also the content surrounding the data to explain the topic area and why it's being presented. In case someone wanted to reproduce our visualizations, detailed descriptive metadata was created. And public health uses highly confidential data, such as cancer, birth defects, hospitalizations, and emergency room visits. So we must ensure that the data is aggregated and suppressed at an appropriate level for security and confidentiality. We had to build a dynamic query system to generate the visualizations with the ability to have counts and rates in temporal or spatial dimensions, and that the user can sort or zoom into the data. All of this was to be presented on a public portal. Both the CDC and the Iowa regulations require 508 accessibility compliance with color contrast and for screen readers. So we launched the original portal in 2013. After 37 months, we were 1 month shy of our goal. And if anyone has done long-term IT projects, being 1 month off is not that bad. We wanted SharePoint as our platform and Performance Point as our visualization tool with a mix of Excel and reporting services. One of the biggest limitations we had was all our data had to be developed into cubes for consumption within Performance Point. Even when we launched the portal, we already knew that our time with Performance Point was limited. Additionally, we were informed that our internal data center that was in the basement of our building that was built in 1952 had 2 to 5 years worth of life left. This was due to the Executive Order 20 of 2009, which basically had state IT consolidation, which limits the ability to replace our IT infrastructure. Our multiple layers of redundancy were slowly failing, and we had no way of replacing it. The portal's data dashboards had a drop-down selector for year, multiple selectors for county. These dashboards were found to be very difficult in the general public and health organizations to use. All those arrows, the numbers, the abbreviations, they were just too confusing. A major limitation to SharePoint for the portal was the inability to have text boxes or help, as everything had to be built on a grid. This was kind of how I felt during the build process and immediately after our launch. I heard the complaints, the issues, the problems, but really, there really wasn't much of a way for me to resolve it. The portal met all of the CDC requirements, but it just really wasn't user-friendly. So during our 2016 portal facelift, IPHT began the process of exploring other options for the portal. We knew that Performance Point had an end-of-life roadmap that was already published by Microsoft. This, combined with the aging data center, meant that a plan needed to be developed over the next 2 to 3 years. A cloud-based system was looking much more feasible for a long-term solution. This prompted our IM staff to begin a detailed search for a potential BI solution. It would have to work with our current data structure. It must be managed by our information management, and it needed to have at least the minimal CDC portal requirements. 5 potential solutions were reviewed. Stay with Microsoft SharePoint, but transition to BI. Or we move to Tableau, Amazon QuickSight, Google Data Studio, or IBM Cognos. In 2017, I decided to explore Tableau closer because on paper, it really looked like a good fit for our organization. And now it's time to conduct a full review. IDPH started with 15 copies of desktop Tableau. The tracking program we connected to the existing data cubes of the original portal and developed a proof of concept of all 98 dashboards. Our current department website is built in DNN or .NET Nuke content management system and hosted on AWS. So we used that platform to recreate a full demo of one topic area that had content, data, visualizations to ensure Tableau and DNN would fulfill the requirements, and it did. Remember when I said our IM said I had 2 to 3 years to come up with a new solution, of which 18 to 30 months were left? Well, in the third quarter of 2017, we were told the timeline had changed slightly. We only had 6 to 8 months to get out of the basement. The data center air conditioner was going out, and if it goes out, the whole system goes down, and so we had to get out. This meant that I had to plan, develop for an entirely new portal system, while in tandem our department was facilitating moving everything to the cloud, but they had been planning that for the last 18 months already. So we purchased a 3-year Tableau subscription because I really wanted an annual a stable annual cost for budgeting purposes. The tracking program and the department, we split it 50-50. Our IM created new Tableau SQL data connections that were pre-aggregated that were not pre-aggregated like the previous cubes. Because we already recreated all the visualizations, we just connected them to the newly developed Tableau data connections. Tableau extracts were generated and moved to the public server and used as the final visualizations. We partnered with the University of Iowa to conduct a clear language review. So a lot of our techie difficult words were brought down to basically an 8th grade level. The tracking program created and populated the web pages in DNN for both content and visualizations. And the new revitalized portal was launched in May of 2018, only after 7 months of work, much less than the 37 months to plan the previous portal. A huge benefit of moving to the cloud is near zero downtime in AWS. The portal was launched and we're getting great reviews and user feedback. But as with any online publication, we'll continue to tweak and improve through user comments. Since moving to the Tableau server, we've also been working with our Tableau Success Manager to develop a roadmap for Tableau, and we can measure those improvements. I'm using various qualitative and quantitative methods to evaluate and evaluation techniques to show the benefits of going to Tableau and AWS. This includes return on investment, FTE savings, error reduction, data modeling, and content analysis. Training the development of a community of practice and the department-wide Tableau user group were also key priorities. We were hoping to have some benefits of going to Tableau. We actually got them, and much more. We've already seen a reduction in staff time. IAM staff time went from 1 full FTE paid out of my grant to a half FTE. And this is with an increase in the number of data sets being loaded annually. In previous years, I was loading 2 to 3 new data sets a year. But now, I'm loading 3 to 4 new data sets a quarter. I'm doing 5 times as much work with half the amount of IAM time. Programs can change dashboards that feed the portal without lengthy business required documents and IAM support. I went from weeks to hours to make a change. And data can be more dynamic and no more constrained to cubes. It's much easier to join data sets together and to examine the correlations. And data suppression can be done within Tableau, creating the flexibility so we can suppress either the numerator or the denominator, whatever is needed. We can respond to emergencies and publish needed data quickly for responders or the general public. Based on user feedback, our end users are loving the new portal. And creating maps is much easier. I have saved over 100 hours in the last year by using Tableau instead of ArcGIS. And return on investment. I've also saved the department 4,000 hours over the last 18 months by using Tableau to assist other programs with either survey analysis or data analysis. This equates to 2 full FTEs besides my own FTE of 2,000 hours. I suggest programs I consult with that to use the time savings to improve their data, explore new data, or dive into new aspects of the data that they've never been able to do before. The focus of IPH is to use Tableau to enhance data usage, not supplement or replace employees. While we're working on the portal, the process of complete data migration was ongoing. Has anyone felt like this during their planning phase to cloud migration? AWS migration has been progressing prior to and during the portal rebuild. IPH loaded the new public Tableau server into AWS, which is the same location as our website in DNN, from the beginning so we wouldn't have to migrate it at a later date. As a side note, during this time, our department also went from an Outlook-based email system to a Google email. This included migrating 5 terabytes of department, division, bureau, and individual drives into Google Drive. The cloud pre-migration planning continued to move ahead for almost 2 years, conducting an application inventory and correcting any problems we found. The application inventory was used to determine what will be migrated and the status of those applications. The first step was our IAM project managers to work with all the bureaus to identify all the applications in the department. Some of these were not currently managed by our information management because they're either small, legacy, or federal applications made for a very specific purpose. Around 50 applications were identified that need to be inventoried and reviewed, and then so our tech teams and team leads reviewed the applications and then gave them an easy red, yellow, or green code. Red designated applications that would need to be upgraded or replaced prior to migration because of incompatibilities. An example was Data Ease. This was a DOS-based application that was built in the mid-'80s and actually requires a Windows 7 box to run that we have on a virtual server. Yellow indicated applications that could be migrated, but it'd be best if they were upgraded. An example of this would be Toxicol, our poison control database. The backend was actually in Access, but there was an option to upgrade it to SQL. So we did that upgrade to SQL. It went from yellow to yellow to green, and we're good to go. And of course, green means applications that are ready to be migrated. The next chapter of migration was to conduct an independent review of the data, servers, and applications by using a service agent software. This process examined the application to determine the memory usage, processor needs, and the input-output requirements. The software provided reports that IAM used to group applications and databases into migration groups. The process progressed enough to where we really needed a contractor to help with some of the heavy lifting. IPHT used a state-approved preferred vendor to speed up the process. The first step was an evaluation of the entire system and map everything, and this took 2 to 3 months. This led to the planning and development of sprints of around 6 months. A challenge of using an outside vendor was the lack of historical knowledge of our system. Oftentimes, they'd try to mansplain our own system to our IM. And so they sometimes even treated our IM staff that they didn't know really what they were doing. This led to the development of a step that consisted of 9 phases, starting with moving and setting up our infrastructure to be developed and tested, and then the various levels of production from highest priority to the lowest. Just like building a house, the first and most important phase is development and implementation of the foundation. This consisted of the domain controllers, infrastructure, networking, and security. The initial foundation was the biggest challenge and by far the most important. It was the one chance that our department had to start over from scratch. As with all phases, this went through development, then test, and finally into production. After the foundation was completed, the following phases were grouped by apps that had things in common or similar networking, connections, structure that were identified during the service agent review. First on the list was our Tableau private Tableau server and all of our data connections to it. We already had Tableau internally, and we also had the public server on AWS. So we migrated that up. The second migration, which was actually rather difficult, was our IDES, our disease investigation system, and our Rhapsody laboratory reporting system, and the HIV reporting system. Because these were all interwoven, they had to be migrated at the same time. So what we did is we migrated over a single weekend. Even though we've been using Tableau for a year, we purchased the on-site server Rapid Start and had Tableau come in to assist with migrating the Tableau server that was housed in the internal data center to AWS, where the public server was housed. This was by far one of the best investments we made. Our IM staff had no trouble setting up the first server, but having Tableau on-prem assisted in making the server optimized. The migration was basically a reinstall into the AWS environment to better align both the public and private servers. We feel that because of AWS expertise and the excellent Tableau customer service, they assisted in us ensuring that we had a solid disaster recovery plan, configured servers that were optimized for the new environment, and provided hints and tips on server maintenance and daily operations. And with that, I'm going to turn it over to Ryan.
Great. Thanks, Rob. Thanks for coming out this morning. My name is Ryan Malecki. I'm a solutions architect here with Amazon. Part of my role is to work with customers who are implementing new architectures and new systems to deal with data. So I want to take a step back and think a little bit about what doing BI and working on data-related projects in the cloud is really about. Starts first by thinking about the data that you're processing. There's an increasing variety of data, an increasing volume of data that customers are dealing with. This can range from traditional data sources, flat files that come out of legacy systems, database, ETL processes, up through more modern, higher volume, higher velocity data sets. Things like application logs that can be generated at the scale of gigs per day, through things like IoT sensor data, where you might be dealing with hundreds of gigs or terabytes per day. The first step we really encourage customers to think about when you're designing a data system is landing all of that raw data. The place that customers usually choose is S3. S3 is our highly durable, highly available object store. It's one of our first services and one of our most highly used. Once you get your data into S3, you don't have to worry about, am I going to lose it? Is it going to be deleted? You can go on to an analysis phase. This analysis phase can take a number of different forms. Commonly, we'll see customers have some sort of a transform step. So reading that data off of S3 and using a tool like Apache Spark or Hive to transform it into a cleaner, more optimized form. On AWS, you can run those tools in EMR, Elastic MapReduce, our distribution of Hadoop. Or we see customers increasingly looking at tools like AWS Glue, which is a fully managed Spark execution environment where you can focus on the business logic you're implementing, not the care and feeding of a Hadoop cluster. From there, you might write your data back into S3 to be used by other tools, or you might ETL it into some data warehousing solution. There's lots of different choices. Amazon's philosophy around data warehousing and databases in general is to really have purpose-built solutions, tools that target the specific problems that you're dealing with, rather than coming out with a one-size-fits-all, it's going to do your data warehousing and make you coffee type solution. So one of the most common data warehouse tools that customers choose is Amazon Redshift. This is our massively scalable parallel processing data warehouse. It's a fork of Postgres, but designed to run natively in the cloud. Can go from tens of gigs of data up through petabytes. So in addition to Redshift, we see customers often moving their data into a more traditional relational database. So RDS is our managed database offering, or even leveraging NoSQL databases. The difference here, a data warehouse, Redshift, is more appropriate when you have a large amount of granular data that you want to be processing, but more optimized for a relatively small number of users concurrently. Whereas something like a relational database is going to be good for already aggregated data that you have a large number of concurrent users accessing your data warehouse. Or you could opt for something that's more cloud native. Increasingly, customers are adopting Amazon Athena. Athena is a fully managed version of Apache Presto, where you're able to query your data that's sitting on S3. With Athena, you send us a SQL query, and we manage provisioning the infrastructure, executing your query, returning the results to you. And so you don't have to do any of the maintenance of infrastructure. Instead, you just execute your queries, and you're paying $5 per terabyte of data that you scan. So for a lot of use cases, it can be incredibly cost effective and get you up and running quickly. And the most important part of all of this is the analysis. Until you have humans interacting with your data, you're not generating any value for your organization. So that's where Tableau comes in. With Tableau, you're able to interface with a range of AWS data sources, from Redshift to EMR, Athena, in addition to all of our relational databases in RDS and Aurora. So instead of having to figure out how am I going to make these connections, how am I going to set everything up, you can just leverage Tableau. So I want to talk a little bit about the different kinds of deployments you can launch for running Tableau on AWS. For both of these options I'm going to talk about, Tableau has worked with Amazon to develop quick starts. Quick starts are guides that come with infrastructure as code, CloudFormation templates, so you're able to launch these in a matter of minutes. You just click a Launch Now button, input a few parameters, and you have a well-architected best practice solution up and running quickly. They also include guides that go into a lot of detail on how to run these solutions. So one style of deployment is a standalone single instance deployment. You'd install Tableau Server on an EC2 instance and have it running in your VPC. You can make it publicly accessible over the internet, or you might choose to make it only accessible within your organization's network. Generally, I'd encourage you to think carefully about how you're allowing access to your Tableau server. Generally, you don't want all of your data sitting there on the internet. So being mindful of security, you should treat your BI server the same way you treat a database. So that's the single node deployment. The other option is a clustered deployment. Here you're going to have a primary and one or more worker nodes that are going to be spread across multiple availability zones. So in AWS, an availability zone is a logical data center. So one or more physical buildings. And our regions are composed of multiple availability zones. This gives you high availability so that if something were to happen in a single availability zone, your application is spread out. You don't have to worry as much about availability. The other component, in addition to having multiple servers running in a cluster deployment of Tableau, is how your users are going to access those multiple servers. This is done through a load balancer, leveraging AWS's Elastic Load Balancer. So one of the most common questions I encounter when I'm dealing with customers setting up a BI deployment is, what size should I pick? How big a server do I need? How much CPU? How much memory? And my best advice there is, don't worry about it too much. With the cloud, you're able to adjust as you go. You can scale up if you realize you have more demand, and conversely, you can scale down. I have customers who do this over the course of the year, that they have a busy season, so they scale up, and then when that busy season is done, they scale down to run in the most cost-efficient manner. There's two scaling strategies. The first is vertical scaling. So this means just moving to a larger server. On AWS, if you're leveraging Elastic Block Storage for your instances, scaling up is just a matter of stopping the instance and swapping out the size. So from the perspective of your application, it looks like you just rebooted something. In this strategy, your application would be offline for a couple of minutes, but this is a really great way for applications that don't have high availability needs, which a lot of times, if you ask yourself, do your users need to be accessing the server at 3 in the morning? The second scaling option is horizontal scaling. In this case, you're going to add more worker nodes or take away worker nodes depending on the needs of your users. This can be done in a more highly available way without having to incur downtime. So with that, I'm going to turn it back over to Rob.
Thank you, Ryan. And you can explain that much, much better than I could. Garners 5 ways to migrate applications to the cloud, and these are based on need and availability. If the service was available in AWS, we would just use the existing service. If not, we would look for third-party applications that could perform the service that we need. If not, we were just going to maintain the application ourselves. We're just really excited about consolidating all the individual servers. We're going from multiple independent servers to consolidated servers that have similarities together. Now, Department of Public Health collects and stores massive amounts of confidential public health data. Birth and death records, disease investigations, including all those STIs, immunization records, licenses of doctors, nurses, beauticians, plumbers, the location of all the radioactive material in the state. This information could include date of birth, social security number, names, addresses, diseases, reason you were hospitalized, reasons why you were discharged from the hospital, and even the method and amount you paid for that hospital visit. The concern of administrators and legislators was how to handle all this information in the cloud. So by moving to AWS, we incorporated continuous scans of all the data to identify this type of public health information. It is also encrypted within the app or is stored on the Gov side of AWS with CGIS certification depending on the needs. Amazon Console was also used to alert be emailed if there's actually any problems. And we use Okta for Tableau for multi-factor authentication. So what's gone well so far? First success was our previous experience in AWS and migration. The decision to move Tableau and away from SharePoint and Performance Point was one of our pivotal points in this process. We previously migrated our website and SQL from our data center to AWS, and this gave our staff time to learn the basics of cloud computing. We also migrated Tableau from one AWS center on the West Coast to one on the East Coast. We have 5 staff who've been involved in all aspects of this process from the beginning and have gone through several trainings over the past 2 years to prepare for the migration journey. After the initial training, they actually set up a box in AWS they really called a play period sandbox. Now this is a pay-to-play process, so basically you turn it on. They're able to go in there and they can test different theories and different applications, erase it and start over. They can really practice, but the idea is you only pay while it's being used. For an example, we would turn it off on the weekends to save the department just a little bit of money. Here are some of the positives of moving to Amazon Web Services. Cost savings, no more hardware cost, replacing hard drives, restarting servers. We don't have to check the temperature of the AC anymore. We have time savings. You don't have to order the servers. You don't have to go and put them in and install them. You don't have to image all the, and you don't have to use all that staff time. Need a server? We'll just set one up within minutes. And then there's performance increase. We don't have to worry about the optimization, the downtime, the quality of connections. We actually architect for redundancy with multiple availability zones in AWS. And of course, ease of maintenance. You just update your software and we're done. What would we have done differently? First thing, we would have started earlier. Even though 2 years of planning seems like a lot, truly never is enough. The team is always thinking of things they would have loved to have reviewed better. Remember, we had 20 years worth of a tangled mess in the basement to undo. The process has moved at the speed of government. I'm sure you guys know about that. Contracts take time, multiple layers of approval. We're constrained by the policies of our OCIO. And better communication. Communication within the department, communication with our OCIO, communication with AWS and Tableau, our contractor, and making sure everyone is on the same page and moving forward together. We've migrated roughly 50 terabytes of information so far. So you make sure that all the programs are up to speed. A few things to take away from our experience in migrating data and applications to the cloud and AWS. Start your planning early and make sure you involve everyone who is all the required staff. Conduct a comprehensive inventory to ensure all applications and data will survive the migration. This includes a full app inventory, prioritization, and a consolidation plan. And don't be scared to start from scratch, because build your infrastructure for the future of your organization, not what you have right now. So who'd like to see a few examples of using AWS and Tableau together? I'll demonstrate some value-added example that shows the return on value during an emergency response. So in the spring of 2019, the Missouri River Basin in western Iowa experienced severe flooding. More than 60 levees were breached, 3 counties flooding over 145,000 acres. Of course, most of this farmland. In 2017, the IPHT program actually did a data sharing agreement with the Department of Natural Resources for a nightly copy of the private well database. This allows IDPH to utilize these data during an emergency response. Seen here are all the private wells in Mills County, Iowa, that were potentially impacted by high water. This dashboard allowed us to not only identify the wells impacted, but if needed, could provide the list of addresses, well IDs, or other information for responders, the ECC commander, or the section chiefs in the Emergency Command Center. IDPH coordinates the Environmental Health Response Team, or EHRT. It's actually my wife runs that team, so I had to give her a little kudos, to support post-flood recovery efforts related to restoring private well service and conducting rapid assessments for recovery needs and property cleanup. In past flooding events in 2008 and 2013, multiple counties received requested information on private wells and which ones were impacted. So they could prepare and they could service those wells for water sampling or remediation. The state was unable to provide that information in a timely manner, and so that's really what prompted us to write that DSA. IDPH transitioned from Google in 2017, and with these new resources, we built a quick Google form that could be used to collect needed information at the point of service. The new technology has allowed EHRT to create an environmental health services assessment tool using the Google form. This tool could be used by EHRT to collect the data in the field by simply completing the Google form and submitting it on an electronic device. The Google Sheet that is being updated on Google form is linked to the Tableau dashboard that's on the server housed in AWS. I can now access the server anywhere instead of having to be on-prem at IDPH that we had to in the past. This allows me to be in the field as a technical advisor. This allows me to be in the Emergency Command Center assisting there, or I could simply be sitting at home with a margarita. On the left is every well in Mills County. While on the phone with the the EH coordinator in the county, he directed me to the northern east-west road, the eastern north-south road, and the southern east-west road impacted. And with minutes, I was able to use the exclude option in Tableau to have a map of only the impacted wells. I've used a lot of mapping software in my day, and nothing else was that quick or easy. When this was presented to the ECC command, I was asked to take that, put in ArcGIS, provide them with a PDF with XY coordinates for each well on the dot. That way they can provide the responders, the map, and a GPS device that they can go out and they can locate each well. So I told them, I can step back, I can get in my DeLorean and go back a decade and provide them an XY coordinates on a map, or they can look at the new technology that we have. Hovering over the dot gives you detailed information on the location, such as name, address, phone number, and well ID. Additionally, there's spaces there for has the well been tested, has it not been tested, or what other services have been provided. Needless to say, the ECC command loved it, and I immediately made them interactors so they could access this map at any time. The EHRT team members visit each site, and they fill out a survey, submit it, and then I update the data hourly, and now the ECC can see in near real time the red turning the green as the community is receiving services that were requested. Even more important, Tableau allows for other data that is collected and visualized at the time to determine are other services needed in areas of special needs. This provides strategic response to specific needs quickly, and during a disaster, this can actually be life-saving. The best part of the tool is technology is transferable, and you can use it for any disaster, not just wells. You could use it for avian flu, Ebola, measles, or tornado, or heck, you can even use it for the zombie apocalypse. IDPH has never been able to use this type of rapid data collection. Google has allowed us to collect information, Tableau has allowed us to visualize it, and AWS has allowed us to access this information from anywhere. If I can leave with a few pieces of advice today, Take time and do your homework when planning a software change or transition to a cloud service. Utilize your customer success manager to assist in promoting Tableau throughout the organization. Work with your AWS representative to identify current and future needs of your organization, and never underestimate the value-added benefits of using both Tableau and AWS. Even if you have plans for Tableau and AWS, think outside the box on additional ways these products and services can be used within your organization to simplify, enhance, or to automate the process. Thank you.
We have about 10 minutes for questions. If anybody has any questions, please, if you can make it to the microphone in the center of the aisle, that would be greatly appreciated.
Hello, I have a question for Rob. Rob, great job. I was hoping you could talk a little bit about any improvement in health outcomes specifically. You talked a lot about the technology enhancements, et cetera. Can you talk about any differences in public health that this migration has had an impact on the people that your agency serve?
Absolutely. Probably one of the biggest impacts of moving both to Tableau and AWS is the ability to get the data to people quicker. Like I said, because our old process was labor intensive for information management, that was a bottleneck. Now we're putting 5 times as much data out there. So it might not get to the public as quick, but the thing is getting to the programs, and so we can analyze that data. I can go to a stakeholder meeting and I can actually bring the data from our database and do it live there instead of, let me check on that, I'll get back to you in a couple weeks. I've got to go pull it from our on-prem database because I don't have access outside. So I think that is the biggest thing. We can get it to the programs quicker, and we can use that data anywhere and during one-on-ones or group settings to try to do simple analysis, provide them maybe a file, or make answers, and so further questions can be asked during that time.
I have a question for the both of you. In your respective area, what was the biggest problem that you encountered when doing this project? So one for each.
What was the biggest problem during the process?
Yes.
Working for the government. As you know, everything in the government takes a lot of time. Probably one of the biggest things is the timetable. You know, if you have all the time in the world to do this process, that's great. But if you're constrained by something, either budget constraints, we all have a budget that we have a deadline on and we get new money the next year. Or our air conditioner was going out in the server room. So by having those constraints, maybe we take shortcuts or don't do things as thoroughly as we'd like to do, but, or let's get it up there now and we'll fix it later. And so that's why having a good plan and a strategy moving forward is one of the most important things you can do.
Sure, I'll answer that as well. So I wasn't working with Rob on this project, but in general, my experience, customers that are working on a migration, one time, whether you're in government or working in the private sector, IT projects always take longer than are expected. The other thing I'd say is really, as Rob alluded to, bringing in experts. When you're in a migration, there's a lot of things that are, as AWS likes to say, undifferentiated heavy lifting. Things that aren't adding value to your organization specifically, but are common tasks that have to happen once in the course of a migration. And bringing in a professional services organization that does this day after day after day and can quickly pull in a playbook and execute on that can speed up the process and deliver a lot of value.
And I'll add on to that, another limitation was our staff was doing this migration while doing their normal job. And so that was the other thing is, I have a full FTE, I have 2,000 hours a year I'm already doing. How am I going to squeeze in 500 more hours to do migration in this process? And so that was one of the other big limitations.
Thank you. Oh, okay, go ahead.
Hi, Rob. I have a quick question. Can you elaborate more on how your responders are able to use your dashboards to act on the data? In other words, does the data have to be pushed out to them, or is it accessible via mobile phone for them that they can, you know, hover over the geocoded point and see, with regards to, let's take the well example. Thank you.
Absolutely. So basically what I did, I created a Tableau dashboard. And so I had it so you could hover over, you could circle a group of wells that were together. Once I circled those, it brought up another dashboard, another page on that dashboard that gave the phone number, address. Basically, it is a table. And so what we do is strike team 1, they're going to do these because they're regionally together. Strike team 2, strike team 3, and basically we printed them off a sheet every day and said, here are the wells that you're going to work on today. Basically, that simple Google form, all they did was they type in the well number as the first thing that they did, or if there wasn't a well number, another page, they added in a new well number, and that was the unique identifier we used to link the two data sets together. And so by that, all they needed to know is where to go and what the well number was, and then they basically were feeding us the data instead of the other way around. The true dashboard in the view was really for the people in the command centers. So we could feed that information back to the locals so they know exactly what's being responded. And once you get out there, you don't know if this is going to be a 5-hour project or a 5-week project. And so by doing this, we can see how rapidly they're progressing. And so we can update, and then we update the governor's office and everyone else on how long this is going to take.
Hello, I have one quick question. So what is the version of Tableau server you used when you started with?
I'm not for sure. Actually, a little side note, I'm a statistician and a data scientist, so I'm a front-end person. I pay by IT people to make sure all this stuff's running. We are using the most current version. Once a new version comes out, we give it 2 weeks to test, and then we automatically upload that. So whatever the newest version is what we're using.
So it's on 2019, not the 2018 version, because there's changes on, and there has to be a migration process. So I was trying to see if you ran into any issues when you migrated.
No, not really. We try and anticipate, and that's usually why we give that 2-week lag time. I know there have been problems and things not working and everything. Lucky for us, we test it, we bring it up, and it's all worked. And so we push it to production, and so we haven't had any problems. But I do know that they do check with Tableau and the forms and all that to ensure that that 2-week window, what bugs have been popped up. But we haven't had any problems.
So once the Tableau server is in AWS, the upgradation process is not like how it is handled compared to the
honestly, I have no clue. Again, I pay my IT guy to do that, and magically I walk in the next day and it's done. And so I'm really not sure, but I can get you that answer.
Sure, thank you.
All right, it looks like we're at time. So thank you everyone for coming out. And if you get a chance, fill out the survey in your app.
Thank you very much.